So going to our 2.4 notes. We're not going to bother with this warm-up because we already did a warm-up that was similar to that, actually. All right. So today we're talking about something called proofs. And proofs are basically a fancy way of showing your work in a way that others can easily read it and things like that, especially when it comes to algebraic proof, which is what we're talking about today. When we go through and solve a problem using algebra, usually you organize your work in steps and stuff like that, right? When you draw the line down the middle of the equal sign and each step kind of follows from the other. Basically, proof is doing that exact same thing, but on the side, putting different little reasons as to why it's okay to do each of those steps, or like saying what you did on each of those steps. So we're going to learn some properties that we're going to use when we do these proofs. And a lot of the properties are going to be super simple things or things that you're going to go, well, duh. But we're going to formalize them with properties and kind of take it from there. So the first property is this addition property of equality. And the addition property of equality is what tells me that I can add something to both sides of the equation and that that's okay to do. So the addition property says if A equals B, then A plus C equals B plus C. It's what tells me I can add something to both sides of the equation. So just like we did in our warm-up when we added 21 to both sides of the equation, that's this property right here. That's what's going on there. So the same thing then for subtraction property and multiplication and division property. These properties are the things that tell us it's okay to add something or subtract something or multiply something on both sides of an equation. So this one starts the same way. If A equals B, then A minus C equals B minus C, since it's a subtraction property and we're going from both sides of the equation there. In fact, these first four all start with if A equals B. So for multiplication, if A equals B, then A times C equals B times C. You can multiply something by both sides of the equation. The division property also starts off with if A equals B, but then we add something else to it as well. If A equals B and C is not equal to 0, then A divided by C is equal to B divided by C. Why can't C be 0? Yeah, Olivia. Close. You're very close with the whole anything divided by 0. But is it, like if you go take a calculator and divide by 0, what happens? Let's do it real quick. 8 divided by 0. Divide by 0 error is what happens. Oh, now we can see it. You can't divide by 0, right? That's one of those things we cannot do. So that's why C can't be 0, because we're not allowed to divide by 0. All right. Then we have two more properties, the substitution property and the distributive property. So the first one, the substitution property, if x equals y, then x can be substituted. Wow, spelling is hard. Tituted. I think that's how you spell that. Yes. All right. X can be substituted for y in any equation. And we're running out of room. There we go. If x equals y, then x can be substituted for y in any equation. So that's the property that says I can plug something in. Like if I find out that x equals 3, I can plug in 3 for x and things like that. All right. And then we have the distributive property, which is also one that was featured in our warm-up this morning. This property is A times the quantity of B plus C in parentheses is equal to A times B plus A times C. Okay. Alrighty. So now that we have those properties, we're going to go through and solve some equations, and we're going to put reasons next to each step. So we're going to basically tell what we did in the step to make it work so we can go to the next step. So this first one, when you see proofs, you usually have two columns right here. We have the equation or the statements, and then we have the reasons over here in another column. So we're going to solve the equation over here, and then we're going to go through and give reasons over here. We're going to use our properties in this column. So here we go. If I have negative 5 equals 3n plus 1, your first reason is always given. First reason is always given, and it's just the regular equation given. So if I was going to solve this, what's something I can do here to, like, what's one step I could take?
Subtract 1.
Yep, subtract 1 from both sides. So if I go minus 1, and then what I'm left with down here, we get negative 5 minus 1 is negative 6 equals 3n. And so whatever I did right here, that's what goes under this reason. So what did I do here? Subtracted. So subtraction property is what goes here. And so that we don't have to write property of equality a bazillion times, I'm just going to abbreviate it as POE for property of equality. All right. Then what would I do to continue here? Kavya? Divide by 3. Divide 3, we get negative 2 equals n. So since I divided right here, that's where step 3 is division. Property of equality, POE. And look at that, we just completed our first proof. So basically we're just going through and solving it, and then we're stating what we did over here. So if I subtracted, we put subtraction property. If I divided, we put division property. If I add, we put addition property. And that's pretty much all there is to these. So let's go through and do a couple more. Let's do the second one next. Down here. All right, so for this one, we have n over 6 minus 3 equals 10. So that's our given, the equation. What should I do first to solve here? Yeah, no.
Add 3 to both sides.
Exactly, add 3 to both sides. So we get n over 6 equals 13. And since I added 3 to both sides, what property is that? Addition. All right. What's the next step? Multiply both sides by 6. So the 6's cancel over here.
What is multiplication?
Yep, that's going to be multiplication. So n equals 78. and that's multiplication.
Why was it multiplication?
Because we multiplied by 6 on both sides.
I know, but see up there how we divide, why would we not divide for that?
Mhm. So when I divided on this one, it was division property. This one was already, it was n divided by 6.
Oh, so
And so to undo that, we had to multiply. Yeah, it's whatever you do on both sides that's the property. Exactly. All right. Now we're going to do a little bit longer one. Number 3. I'll let everyone finish writing here real quick. Yeah, Naya.
oh, we're not starting yet.
What do I do first here?
Add 2 sides.
Close. You could. There's one thing I would do first, though. How did we start on the warm-up? Yeah. The distributive property. Yeah, that's how we started on the warm-up. And that's usually, if you see parentheses here, I would deal with the distributive property first just to get that out of the way. It's the way that we can make the least amount of mistakes usually. So we get 3x minus 12 equals x minus 2. But we will end up adding 2 to both sides, just not quite yet. Or we could. The nice thing is there's not always one exact way to do these. You can do different steps, just like with any algebra equation. You can kind of do steps in different orders. Tavia?
Subtract x.
Yeah, subtract x from both sides is probably what I would go with for the next one, just to keep the x's positive and to keep everything, yeah, so we don't have to work with negatives here. So if I do that, if I subtract x on both sides, we get 2x minus 12. And don't forget that this is still a negative 2. Don't forget to bring down the negative with it. And since we subtracted x from both sides, that is the subtraction property. Then what do I do? Olivia? Exactly. Add 12. So we get 2x equals 10. And that was the addition property because we added 12 to both sides. All right. And then what's my final step? Divide by 2. With our division property. Okay. So those are our properties of equality. Those are algebraic proofs. Once you have that, go ahead and turn the page. We're going to learn about 3 more properties. Three more properties. And I'm going to zoom out a little so we can see them. Okay. So in geometry, these properties are going to be used a lot more often. We have 3 properties: the reflexive property of equality, the symmetric property of equality, and the transitive property of equality. So here they are. The reflexive property, sometimes I think of as kind of the duh property. It's A is equal to A, or something is equal to itself, like 15 is equal to 15, or angle 1 is equal to the measure of angle 1. This property becomes more useful when we start talking about proofs involving triangles. We're not going to see the reflexive property used a whole lot in early on proofs. But we will see it used later in geometry. So we're learning about that one. And then we have the symmetric property of equality, which basically says that you can switch the order of the equal sign, or switch the order that things are on the equal sign. So if A equals B, then B equals A. If n equals 2, then 2 equals n. Or AB is equal to BA. So if it helps you to kind of remember it, symmetric is switching. the property that says I can switch. Reflexive is like a reflection. It's looking in a mirror. It's something is equal to itself. And then the last one, the transitive property. If A equals B and B equals C, then A equals C. So it's kind of cutting out this middleman here. So we're saying that these two things are both equal to the same thing, so they must then be equal to each other. So like if y equals 3 squared and 3 squared equals 9, then y equals 9. Or if measure of angle A is equal to measure of angle B, and measure of angle B is equal to measure of angle C, then measure of angle A is equal to measure of angle C. We're cutting out the middleman. There's actually a poster in here about this right behind Olivia. Transitive property poster. It says, if a bear is, if a bear is chasing your friend and your friend is chasing you, then by the transitive property, the bear is also chasing you. Transitive property of bears. So there's all kinds of ways we can apply the transitive property, and it's going to be one that we see quite a bit here. So what we want to do is kind of look at these different examples and match up the properties to these examples. So we can use with all of these. Now we have the addition, subtraction, multiplication, division, distributive properties, all of those. And now we have these three new properties, reflexive, symmetric, and transitive. So let's look at a couple of these together. The first one here, if measure of angle 1 equals measure of angle 2, then measure of angle 2 equals measure of angle 1. What property does that look like? Almost. Because transitive, remember, is the one that has like three equal signs going on here.
Symmetric.
Symmetric. Yeah, so basically all we did here was we switched the order of these, right? Symmetric is switching. This is the symmetric property. All right. How about this one? If AB is equal to RS and RS is equal to WY, then AB is equal to WY.
Transitive.
That one's the transitive. There we go. Because that's where we're kind of cutting out this middleman of RS and getting AB and WY equal to each other over here. All right. This one, if measure of angle 1 equals 90 and measure of angle 2 equals measure of angle 1, then measure of angle 2 equals 90. That one looks like transitive. It's also, so this one's kind of one of those ones that could either be substitution or transitive. I could see an argument for both because these two middle things here are not the same. The end ones are. So technically, we're substituting angle 2 in the place of angle 1 right here. But also, I would accept transitive. So you could have substitution or transitive. Because the net effect here is the same. Okay. Number 6. If AB is equal to CD, then 1/2 times AB is equal to 1/2 times CD. Remember, we have our properties on the other page as well that are options here. Multiplication, that's the one. Because we took 1/2 and multiplied it on both sides. So this one is multiplication. All right. Number 7, RS is equal to RS. Reflexive. All right, 2 more here. See if you can figure out number 8 and number 9 on your own, and then we'll talk about it. Try number 8 and 9. Pick a property that goes with those.
I probably both. It's kind of a combination. Addition is also. Go with the button. Yeah.
All right. Talk to people around you. Compare real quick.
I did. And what'd you get for 8?
Yeah, transitive 8, I can figure out 9.
Would you say what substitution?
9 is kind of.
Did you get 4, 8?
I'm not sure if it's right. I said subtraction.
Yeah, makes sense.
Yeah.
Makes sense.
All right, number 8. Thumbs up if you put transitive property. That is correct. Number 8 is transitive. All right, because we're cutting out that angle 2 middleman here and having the ends, angle 1 and angle 3, be equal to each other. All right, and then number 9, what did we put? Anyone want to share with us? Addition, that's correct. Because we're taking AB and adding TU to it and RS and adding WY to it, but TU and WY are equal, so we're adding something that's equal on both sides. You could also kind of combine it with substitution because technically we're not adding the exact same lettering to both sides, but the net effect is the same. I would just call this addition probably. All right. So, along with this, we also have properties of congruence, and they're the same properties, but we have to remember something. Lengths are equal to each other. So like the length of segment AB and the length of segment CD, those can be equal. But segments are congruent to each other. So I could say AB is equal to CD because I'm talking about lengths here. But if I wanted to talk about segments, if I said segment AB, I would have to say that it's congruent to segment CD. Because congruent is for things, equal is for numbers. And these represent numbers and these represent things. The congruent symbol.
No. Oh, that's equal.
Oh, the equal sign, yeah. Here. And then the same thing is true for angle measures. Angle measures are equal, but angles are congruent to each other. So the same thing happens. You could say that measure of angle 1 is equal to measure of angle 2. The little m denotes that we're talking about the measure. Or you could say that angle 1 is congruent to angle 2. Remember, things are congruent, numbers and measures and lengths, those are all equal. So in that kind of off of that same thing, we have properties of congruence. So we have like the reflexive property of congruence and the symmetric property of congruence, and it's denoted with POC instead. So we had POE and POC. So like, for example, with the reflexive property of congruence, you could say like figure A is congruent to figure A, or angle CDE is congruent to angle CDE. Something being congruent to itself is the reflexive property of congruence. Same thing with like the symmetric property of congruence. It's the thing that says you can switch the order of things that are congruent. So it's basically all the same properties of equality except with congruent symbols and things instead of numbers. Okay. So go ahead, try 9, 10, 11, and 12. They work the exact same way as that 3 through 9 worked. Go ahead and try those real quick. Put the property that goes with it. Remember, if it's a property of congruence, it needs a congruent symbol. If it's property of equality, it will have equal symbols involved. And these are all properties from this page. No, those are good. You got it. All right, and then talk to the people around you about what you picked.
Symmetric, transitive, symmetric, reflexive.
Yeah.
9 and 11.
So I've done that. Go symmetric, transitive, reflexive, the last one, and then I just did the one.
Oh, Q's right.
This, I think this is symmetric too. These two.
Yeah.
Oh, see.
Okay, so figure, figure A, you know, which is B. Okay, figure A is equal to.
All right, what do we get for number 9?
Symmetric.
Symmetric. Is it property of equality or property of congruence? Congruence. So we'd put POC because we see the congruent symbols here. How about number 10?
Transitive.
Transitive. And that's going to be POC as well because it's got congruent symbols going on. How about 11? Symmetric. Is it POE or POC? POE. Because we have equal signs. How about number 12? Reflexive. POC, exactly. All right, the last kind of question that we're going to talk about together is these ones down here. 13, 14, 14, and 15, apparently, because the numbers are duplicated there. All right, so addition property of equality. If measure of angle J equals 30, then measure of angle J plus measure of angle K is going to be equal to 30 plus measure of angle K. So basically you look at the difference between here and here and notice that on the right or the left-hand side, angle K was added. So on the right-hand side, angle K should also be added. That's how we want to finish that kind. All right. For the first number 14 here, distributive property, 3 times x plus 7 equals 30. We want to fill in these two blanks here. What should go in the first one? 3x. Because we're just multiplying it by both of them, right? What goes in this blank? 21. And then equals 30. 3 times 7. Yep. All right. Here we've got transitive property that we're supposed to use. It says if 3x plus y equals 7 and 7 equals 5x minus 2y, then what? So here's the trick on the transitive property ones. Figure out what the middleman is. In this case, it's the 7 because they both have 7. Get rid of that and put the ends together. So we get 3x plus y equals 5x minus 2y.
That always works fine in the middle.
Yep. Get rid of that middleman here and then put the two ends equal. Yep.
Do we include the equal signs?
Include just one equal sign. You don't need two. All right, and then lastly, multiplication property of equality. This one works just like number 13 did with the addition property. We had measure of angle J equals 30. Then 2 times measure of angle J equals what? 60, or you could go 2 times 30 for now, or 60. Either of those would work just fine. If you want to showcase the property itself, you put 2 times 30. If you want to just have, the answer there, you can go 60. Yeah.
Number 13, why is it 30?
Because we had measure of angle J equals 30 here, right? And so what changed from measure of angle J to this part here? We added K, right? So the same thing needs to happen on the right-hand side. We have 30, and then we're adding measure of angle K, since that's what changed from the first step to the second step. And that's probably the weirdest one out of all of these 4, but that is what they're looking for there. Okay, so on a scale of 1 to 5, 1 being I'm completely lost on the properties, 5 being this seems pretty easy to me, what are we feeling? Okay. Go ahead and turn the page. We're going to look at some of these problems for homework. Okay. We're going to do 1, 2, and 3. But with 1, 2, and 3, find either your own extra paper or the back of the packet and use more room to do these 3 because you have to put the steps or the reason by each step. So on these 3, there's not enough room to solve them right here. So just as a heads up, find either the back of the packet or another blank page or your own separate paper and do those ones extra or use extra space there.
I need an extra paper.
Then also 7 and 8 and 9, 10, 11, not 12, and then 13. So on practice A, 1, 2, 3, 7, 8, 9, 10, 11, and 13. And then turn the page. We're going to do a little bit of practice B as well. Not all of it. From practice B, we're going to do 5 and 6 and 7 and 8. Yep. Practice B is 5, 6, 7, 8. Practice A is 1, 2, 3, 7 through 11, and 13. So you've got a couple minutes right now. Start giving those problems a try. If you have questions, ask questions, and go from there.